I do have internet problems, so that the connection has disconnected. So, however, uh, okay. So you have to operate a predicate on that particular selection here. If you operate predicate, then such kind of selection will be called as, so such kind of conditions are called as selection. So look at this. All these predicates will be so apply on complete row. So because of application on complete row, it could be displays horizontal subset of the relation. Horizontal subset of the relation. Let me show you how the horizontal subset could be. For example, I'd like to display the details of all employees who are salesmen. For example, this is the condition here. So select everything from EMP where so job like SALESMAN, salesman. If I were to select this one, observe this particular kind of query here. This query could be display complete information about each and every so employee, but number of employees are restricted. Number of employees are restricted here. This restriction could be based on one condition, one predicate. The predicate is called as so job like salesman. This is the predicate. Okay. Based on this particular predicate, we have a restrict several number of rows here. So that is why it is going to be displayed the horizontal subset of the relation. So, however, how it could be specified here in the sense, this is the way of so specification of selection in terms of relational algebra. So just before we wrote something here that is job like the salesman, how you could specify this one here in the sense sigma, so job like so salesman, okay, you may be right in capitals or lowercase letters, single quotes, of relation will be EMP. So this is the way you have to specify. This is the way you have to specify. In this way, you have to specify. For example, display the details of all employees whose salary is greater than so 2,500. For this, we may be right. Select everything from EMP where so salary is greater than or equal to so 2,500. This is the query. We may be right. So this query could be converted into so relational algebraic selection will be sigma. So salary is greater than so 2,500. Of course, so greater than or equal to 2,500. So of my relation will be, this is my relation. My relation will be EMP. Okay, like this you have to specify. In this way you have to specify here. So finally, how this could be worked out here in the sense, so it could be the predicate might be includes greater than or equal to, less than or equal to, not equal to, and or not. All these things will be gets used. So how this could be displayed here? Let us consider this is the whole relation R. This is the whole relation R, and it could be displayed so horizontal subset of that particular relation. Okay, so this is the way to write your horizontal subset, something like this. You have to specify some predicate here and then followed by your relation. This is the way to specify. For example, display the details of all employees so whose department number equal to some 20. So for this, so DEPT NO will be equal to some 20 here. 20 of our relation is EMP. So in this way, you have to specify. This is one kind of specification of your so query here. Okay. So same kind of queries will be asked you in your final examinations. You are also expected to write in the same fashion. Okay, same fashion. So look at this. Only one relation has been taken into consideration. Because of it is being taken single relation, this selection will be called as unary. So algebraic, algebraic operation here. This is unary operation. Okay. Then followed by the converse operation will be binary. Projection. Projection in the sense, previously selection will be always taken some predicate and it could be displays complete information of some entities or some rows, but number of rows will be restricted because of this particular so predicate here. Okay, but here in projection, it could be displays. So the vertical subset in the sense. So it could be always select certain number of columns from the R. Okay, so vertical subset will be displayed for this particular relation R here. So you could see this vertical subset will be so always specified while displaying that particular thing. So it could be eliminate the duplicates. And how this could be taken into consideration here in the sense, this is the general form of projection. And let me give you some pictorial representation how it could be. Let us consider this is the relation. So let us consider this is the relation R, and it could be display certain number of so vertical subset here. Vertical subset in the sense, out of some 6 or 7 attributes, you maybe select some 2 or 3. So that is what the meaning of vertical here. Okay. So look at this. Let me give you some information. So seems like this. So select everything from MP. Let me display employee number, employee name, and department number. Employee number, employee name, and department number. Only these 3. So for example, so select EMPNO is one particular attribute, E name followed by DEPTNO from EMP. So whether it could be useful for us or not, that could be out of matter, but we have been selected out of so 4 plus 4, 8 attributes. We have been selected only 3 attributes. Okay, this is a vertical subset of the actual set, that is EMP. So such kind of displaying, such kind of selections will be called as projection. This is called as the projection. So the same thing could be written in terms of this one here, something like this, in this way. So pi of, so first one is EMPNO, comma E name. Okay, you need to write complete words. I'm unable to draw using mouse, so that is why I have given ENO. You need to write EMPNO, so followed by E name, followed by DEPTNO of EMP. Okay, something like this. It could be. So actually, EMP does have approximately 8 different kinds of columns are there. Out of 8, you have been selected only 3. Only 3. So this is a vertical subset of so your actual relation, that is R. Need to understand one thing here. In vertical subset, complete number of rows have been displayed. You please observe this one here. We do have totally 14 rows. For these 3 columns, 14 rows will be gets displayed. Okay, so that is why in vertical subset, everything could be displayed here. Everything could be displayed. So in vertical subset also, if you want to let me say restrict some more data or some more kind of data, you have to operate projection over selection. Projection over selection. How that could be? So pi of attribute 1, comma attribute attribute 2, comma and so on, comma attribute n of, you need to take sigma some predicate p of so the relation R. If you have to restrict in vertical subset also, if you want to do some kind of restriction, yes, you have to operate something like this. The combination must be always like this. So this predicate will be, selection must be always inner operation, and projection must be always outer operation. You please remember this one. You never operate something like this. So some predicate followed by so pi of some attribute followed by the relation R. It is illegal. It is illegal. You are not supposed to operate this one. You are not. This is not valid. This is not valid here. You please remember this. This is valid. Okay. How this could be achieved here in the sense, I'd like to display the details of all employees whose employee number, employee name, and department number of department number 20, for example. So we need to follow with a condition where DEPTNO will be equal to 20 here. It is both vertical and horizontal, both will be gets operated here. Okay. So in this perception, how you could write here in the sense, this is the way you have to write. This is the way you have to write. Let me eliminate some for a while. The implementation could be seen in such a fashion here. In such a fashion here. That is sigma. So DEPTNO department number is equal to 20 of EMP. So closing for the place. In this way, you have to satisfy the query what we have written just before at SQL problem. Okay, this is the way. Okay, so this could be very useful and easy to write the selections and projections. And now let us go ahead with the next operation. Operation is union. Union in the sense, so it could be taken two operands. Operand number one, so R, and operand number two will be so yes, and these two will be gets operated with so union. So operand R, sorry, the relation R must be having some number of rows, and relation S must be having some number of rows. So for example, R might be having n rows, S might be having m number of rows in the sense. So R union, so S might be having n plus m number of rows. So that is the specification. And also you need to remember while displaying this particular data, it must be eliminates the duplicates. Look at this. Duplicate tuples must be eliminated. So something like this. And the R and S must be uni-compatible, not union actually. This is uni-compatible. Uni-compatible in the sense, so selection must be taken by you on same kind of data. Okay. So this could be written something like this. Okay, something like this. And how you could done this particular thing here in the sense, it could be done. Okay, let me take some example here. So look at this. This is R, and this is S. Okay, R union S in the sense the entire thing will be called as R union S. How this could be done here in the sense, let me show you one example here. Display all jobs from all departments. So select so job from EMP where the DEPTNO will be equal to 10 union. So select department number equal to 20 union. Otherwise, let me finish up here. What are the common jobs of department number 10 and 20? Analyst, clerk, manager, and president. If you want to perform the same kind of operation in terms of union in algebraic expression, how it could be done? How it could be done in the sense, this is the way. So look at this. You have to select job. Sorry, this is not the way to specify here. This is not the way. First one is pi. So pi of job. Okay. So let me write a DNO. Please try to understand. Actually, you need to write DEPTNO. DNO will be equal to so 10 of EMP. This is first relation. This whole thing will be called as relation R union. So pi of again you have to select job only. This is what the meaning of uni-compatible. Okay, job. So of sigma department number will be equal to so 20 of the relation EMP. Let us consider this is S. Okay. So actually individually it could be gives you some m number of rows. Individually it could be gives you n number of rows. If you operate union, then obviously it could be gives you m plus n number of rows. Okay, m plus m number of rows. In this way, you have to operate the union operation. Okay, union operation shall be continued in this way. And if you understand union properly, obviously you do understand so Cartesian product and intersection and everything. Okay. Then the minus operation, set difference or minus operation. How this could be gets operated here? This could be get operated here. So the set difference will be always gives you how the set difference will be always gives you here in the sense. So a relation R, the elements are the tuples which are available within the relation R, but not in S. Okay, then such kind of otherwise you could also give another statement. Unique tuples in R will be displayed. Unique tuples in R will be displayed here. So let's try to understand. So relation R union S will be equal to S union R. This is commutativeness is satisfied. Relational R intersection S will be equal to S intersection R. This also be get satisfied. Whereas if you go ahead with the relation R minus S must not be equal to S minus R. So unique rows or unique tuples which are available for R will be displayed by this one. Unique tuples for S will be gets displayed by this particular thing. Both could not be same. Both could not be the same. Okay. So try to understand. This is the way you need to specify. And the general form will be R minus S. So here also same. Let me identify what is the unique job for department number 20. Otherwise department number 10. Okay, for department number 10, what is the unique job? So instead of this, you need to operate minus minus. Okay, look at this. Only one value, that is president. And if you go ahead and operate this particular operation, let me say, so here it is 20 and minus. So here it is 10. If you go ahead and operate this particular thing, I'm sorry. Minus. Here it is department number 10. If you go to operate this one, so previously department number 10 minus department number 20, I mean job, select job from EMP where department number 10 minus select job from EMP where department number 20 gives you president. Okay, this is the unique job for department number 10. Whereas if you go ahead and operate this one, 20 minus 10, job for 20, job for 2 minus 10, so then you have to give in this one. So these two values are not equal. So that is why these two are not equal here. So you could operate something like this. You could see in this way. This is R and this is S. And the data which is being taken here will be R minus S. So could we specify phi of let me say job of sigma department number is equal to 10, okay, of EMP minus, so phi of job of sigma department number is equal to 20 of EMP. This could be R minus, this could be S, will be gives you R minus S. Look at the jobs which are unique for this particular R will be given. As like just I have shown here. So 10 minus job from 10 minus job from 20 will be gives you president here. Something like this, it could be given. In this way, set difference is being gets operated. I'll give you some examples and they have to work out everything and they have to submit me in a particular date. Of course, I have already given some assignment to you. Okay, some time is there. After completion of this assignment, I'll give you the same kind of issues. Okay, then followed by intersection. So intersection also the same. You could observe this one. So if you take intersection R and S, the common values in R and S will be gets displayed here. Okay, common values. So let us observe what are the intersection operations here. So all common job types in department number 20 and 10. So intersect. So department number 20. If you take this one, common jobs are clerk and managers. So thereby in department number 10, 3 job types are there. That is president, clerk and manager. And department number 20, 3 job types are there. that is clerk, manager, and analyst. So thereby analyst will be eliminated and president will be eliminated because these two are the common job types between these two. So that is why it has been selected. So how this could be specified here in the sense, today mouse also not supporting me properly. So that is why I'm unable to draw the proper way. So okay, phi of job of sigma department number will be equal to 10 of EMP intersect. So phi of job of sigma department number will be equal to 20 so of EMP. Okay, something like this. In this way, you have to write the intersection. Okay, in this way, you have to write the intersection. And Cartesian product. Finally, the Cartesian product. Cartesian product is always already we have come across this one. We have studied this Cartesian product on the implementation of principal amount, rate, and interest. Thereby, we have been applied some kind of Cartesian product. And what exactly the Cartesian product will be? So look at the example here, then you could understand very easily. So R might be having two elements, that is A and B. S might be having three elements, so that is A, B, 1, 2, 3. Then R cross product of S will be this one: A1, A2, A3, B1, B2, B3. So every element will be combined together with the second so relation here. This is what the relation here. So if you want to specify this one, how this could be select so E name comma D name from EMP comma DEPT. So this way you have to specify FROM. Yeah, you could see. So 14 into 4, 56. Totally 56 rows will be just displayed here. Look at this, how this could be succeeded here in the sense. So R will be sigma, sorry, it is not sigma actually. Sigma could not be there in, so sigma could not be there in Cartesian product. Only pi could be there. Sigma could not be there here. Only pi could be there. So pi of, so E name of relation EMP Cartesian product. So pi of D name of DEPT. So this is the way you have to specify. The Cartesian product will be specified like this. Actually, most of the cases, Cartesian product is useless for us. This is useless for us. So this could be, if you want to make Cartesian product as useful, already I have given some example to you. Kindly go through that particular example one more time, then you may understand very clearly what exactly the Cartesian product is. So this is today's class, and tomorrow we will discuss. So tomorrow probably we will discuss, because a very big topic is there. The topic is join, because we do have many number of joins here. These number of joins are, I mean, equi-join, non-equi-join, Cartesian, outer join, and all these things are supposed to be discussed tomorrow. After tomorrow, so this relational algebra will be gets closed. So then we will see. Okay. This is what about the complete information regarding to relational algebraic expressions. Okay. Meet tomorrow. Today, how many people have attended? Only 14. Okay, we'll see.